Chromatography relies on two different phases. The stationary phase, which in paper chromatography is very uniform, absorbent paper. The mobile phase is the solvent that moves through the paper, carrying different substances with it. The different dissolved substances in the mixture are attracted to the two phases in different proportions. This causes them to move at different rates through the paper. Interpreting a chromatogram. Separation by chromatography produces a chromatogram. A paper chromatogram can be used to distinguish between pure and impure substances. A pure substance produces one spot on the chromatogram. An impure substance or mixture produces two or more spots. So something that is impure will have more than two spots. A paper chromatogram can also be used to identify substances by comparing them with known substances. Two substances are likely to be the same if they produce the same number of spots, and these match in color, and the spots travel the same distance up the paper. We are going to be talking about chromatography. So chromatography now, let's just say that you want to investigate something. You want to investigate a substance. Now, that substance, let's just say you got a leaf. This is a leaf, let's just say. So this is a leaf. Now, what you do is that this needs to be fine. So in order to investigate this leaf, what's the chemicals inside this leaf? You need to chop it up, make it into a fine powder, and you need to add solvent, don't you? You need to add solvent. So you need to use either some scissors, some kind of chopping equipment. So let's just say that those are scissors. And what you need to do is that you need to pestle and mortar. So pestle and mortar. Sometimes you might need to add a pinch of sand. And what else? Now the solvent or the mobile phase for the chromatography will be something called propanone. So that is the solvent. Now there are two ways of doing. So you can use chromatography paper or filtration. So filtration and chromatography paper. Paper. All right, so this is what you do. First, this is your paper. You need to make a line. This is, let's just say that's the baseline. So that is the baseline. You have a sample here. So that's your sample. And then this is your end of the solvent. You need to put it has to be below the baseline, hasn't it? So here is your solvent. So here's your propanone, and has to be below the baseline. Below the baseline. So you need to remove the paper before it reaches the top. Before the solvent reaches the top, before the solvent reaches the top. Okay, so remove the paper before the solvent reaches the top, and then you mark the level. And what is the equation for chromatography? Now the equation RF, so that's the retention factor, is the distance by the spot divided by distance by the solvent. I think that means distance moved, isn't it? Is it distance moved? And then distance by the solvent. Distance moved, distance absorbed. This is the procedure. So A, you finely cut up some leaves and fill a mortar to about 2 centimeters depth. Add a pinch of sand and about 6 drops of propanone from the teat pipette. Grind the mixture with a pestle for at least 3 minutes. On a strip of chromatography paper, draw a pencil line 3 centimeters from the bottom. Use a fine glass tube to put liquid from the leaf extract into the center of the line. Keep the spot as small as possible. Allow the spot to dry, then add another spot on top. Add 5 more drops of solution, letting each one dry before putting on the next. The idea is to build up a very concentrated small spot on the paper. Attach the paper to the pencil using sellotape so that when placed in the beaker, the paper is just clear of its base. Place no more than about 10 cm cubed of propanone in the beaker and hang the paper so it dips in the propanone. Ensure the propanone level is below the spot. Okay, so for this experiment, it works very well providing care is taken over preparing the spot on the chromatography paper. It should be as small and as concentrated as possible. Encourage students to be patient and to wait until each application is dry before adding the next. At least 3 spots should be obtained, and one of these should be yellow due to carotenes. The extent to which any particular component moves up the paper is dependent not only on its solubility in propanone, but also on its attraction for the cellulose in the chromatography paper. The yellow carotene spot, which has a higher retention factor value, tends to move up the paper the furthest. If you look at this diagram here, A is the distance traveled by the solvent and B is the distance traveled by the spot. Have a look at the solvent level, the baseline and the solvent front. Make sure you know how to distinguish between these 3 things.